What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Today we're going to be going through Chem 118C practice problems. This is preparing for midterm 2 from Dr. Nasiri here at UC Davis. So let's go ahead and jump into these problems. Alright, so for this first problem, we're going to go ahead and look at our benzene ring and see that we have a bunch of carbons coming off of it, and our first reagent here is KMNO4 and heat. Actually, both of these are going to go together. So I know that if I have at least one carbon with at least one hydrogen coming off of my benzene ring, in this case I have two over here, then I know this area can get completely oxidized into a COOH. Whereas over here on the left, nothing's going to happen because I have no available hydrogen. So let's go ahead and see the first intermediate. Okay, so here we are at our first intermediate. Now let's go ahead and move on to the next intermediate, which is right here, HNO3H2SO4. This group right here is a meta director. So I know that it's going to add this green group here in the meta location. Okay, so let's go ahead and see what that looks like. Okay, so we also know that this group right here is an ortho-para director, but the para spot is taken up by the carboxylic acid. So that also means we got two hits here. This is the ortho spot relative to these carbons, and it's also the meta spot relative to the carboxylic acid. So I know I'm going to add this green group here, which is going to be an NO2. Here's NO2. And then my final reagent here, if I take this fourth group, I know that this is going to convert my NO2 into an NH2. So here is my final expected answer. Alright, that's number one. Let's go ahead and move on to number two. Alright, for this next problem, again, we're working with our benzylic carbons and our phenol reactions. So this is our benzylic spot. I know if I react NCS, just like if I was going to do NBS, NCS is going to add a chloride onto my benzylic, right here, my benzylic carbon. So let's go ahead and see what that looks like. So here's the next intermediate. I went ahead and added my Cl group onto my benzylic spot. Let's go ahead and see what happens when we use our second reagent here. So this is a big bulky base, and I know big bulky bases are going to go in the less crowded spot. So here's a little proton here. If I take my big tert butyl here, I can actually react this with the hydrogen, kick on a double bond here, and kick out my Cl group. So let's go ahead and see what that gives us. So now I have a nice pretty double bond here, and if I react this with HBr, specifically in ROR, that's going to go through anti-Markovnikov. Anti-Markovnikov means I want to put my Br group on the less substituted side of the double bond. So I can already see this guy has just H's, and then over here, this guy has an H, and then the big benzene ring. So I already know it's going to go on the right side. And here's my final answer. That Br group went on the less substituted side of that double bond because of my ROOR. Okay, let's go ahead and do another one. Alright, so for this third problem, we're still working with our benzylic carbon. Here I see that there's a little H in here, and I know that this group is negatively charged and wants to deprotonate the H, which is going to push on these electrons onto that carbon. From here I see that I have a negatively charged carbon, and I have a primary haloalkane here. Simply take my negative charge and have it go attack this species over here and kick out the Br group. And there you have it. We have our final answer. Not too bad, right? That went through a little SN2 reaction. Alright guys, so this is our final problem. Go ahead and try this one out. See if you can do it. Alright, so we're still working with that benzylic spot right there. And I know I have a strong base over here. This is a primary haloalkane. Pretty good leaving group here. So what I can do is take my OH group and go and hit this carbon and kick out that leaving group. Let's go ahead and see what we get. So this is what we get. Now if I start counting here from the O, label this guy as A, this is B, C, and D. You can see that we have all of those pieces right here, A, B, C, and D. D is still attached to the BR, and A here is still attached to the O that was the nucleophile. And now we have an ether group coming off of our benzene ring. That's going to be important for later. So we just took care of this first group. Let's go ahead and do step number 2. Step 2 here, I take my Mg and ether, and I know my Mg is just going to sneak right in here. Alright, now that we have our RMGX group here, this is our Grignard reagent, so I know that this red bond here is going to be super nucleophilic, and where is it going to want to go? It's going to want to go hit here and kick this group up, and then use a little proton here to quench that H+. Okay, let's see what we get. Alright, so this is the next intermediate we get here after we finish this step 3 and 4. So now we just have one final step. Let's see what happens if I use this H2 in PTC. So this guy is special because what it does is it isolates this ether, and it's going to totally remove it from my benzene ring, and then I no longer care about my benzene ring. My major product is going to be right here circled in green, and I'm simply gonna protonate this side so the O isn't negatively charged. When this cleaves off of here, this O is going to become an OH group. So let's go ahead and write our final product. So we can expect this to be my final answer after I use H2 and PTC. This is a nice special reagent. All right, thanks for tuning in, guys, and we'll see you next time.